Okay, guys, everybody's favorite X day is upon us. Okay, last time we were together, we talked about synthetic division. Okay, that's a key skill for what we need to do in this unit with polynomials. If x plus 7 is a factor, what is the solution? Come on, guys. X what? X equal negative 7. If x plus 7 is a factor, x equal negative 7 is the solution. If x equal 5 is a solution, what is the factor? X minus 5. So you've got to be very fluent in, if I tell you a factor, you know the solution, and going back and forth between them. So the reason this is important with factoring, let's just take a look at an example from a graph. So if I look at x minus 2, that's the graph of a what? That's the graph of a what? Line, okay? That's a line. Come on. This is Monday. You guys can warm up. This is the graph of a line. What is the x-intercept? X-intercept is where it crosses what? Exactly. What is the x-intercept? 2, 0. So it looks like x minus 2 is a factor. What's the solution? X equal 2. So 2, 0 is an x-intercept. Now, what if I multiply that line by the line x plus 1? Okay, like that. Okay? So I multiply two lines together. I no longer have a line. I have, what is this? It's a parabola. Where are the x-intercepts? Negative 1, 0, and 2, 0. Okay? You can see them on the graph, 2, 0, and negative 1, 0. Let me make it just a little bit. You can see on the graph that the intercepts are at 2, 0, and negative 1, 0. Can you see without the graph that the intercepts are at 2, 0, and negative 1, 0? Yeah, you can see that from the equation. Okay? What if I were to do something like this? And let's multiply three lines together. Okay? Now, where are the x-intercepts? Look at this. There should be one at 2, what, negative 1 and 1. I see 2, negative 1, and 1. I have, those are x-intercepts. So the point is, I can keep doing this all day long, and I won't, you know. If I added, say, x plus 0.5, there'll be an intercept at negative 1/2, okay? So if I keep multiplying these factors, I'm going to keep getting these same x-intercepts that you expect. So let's take a look at what we need to talk about today. We need to talk about roots and multiplicity. So if I had a function, this is a polynomial. This is a pretty complicated polynomial. There's no way I can teach you in parent functions to memorize what something like that does. But our strategy is going to be, if I can get it factored, I can learn some very important things about this polynomial. So look at this one. I'm going to make this a little bit larger. If I look at this polynomial that I just put in front of you, this is what it looks like in factored form. So in factored form, it looks like this, okay? We want to get to be able to graph it. Right now, we're not to where we can graph it, but I can, at this point, you should be able to tell me the x-intercepts. What are the x-intercepts? 1, 0. Yeah, 1, 0. That looks like that one happens twice. And then what? 2, 0. Yeah, negative 4, 0. And negative 3, 0. Okay? So if I were to start graphing this guy, those are all my x-intercepts. That's a good start in how to graph this. If I look at that one that I just did a moment ago, if I didn't know what the graph of this thing looked like, but you knew all the x-intercepts, that would be helpful if you knew everywhere that it crossed the x-axis, okay? So that would be a helpful thing to know. So in this case, this was our standard form, which you saw up here. This was in factored form. Factored form would allow me to find the zeros. And this is the same problem here, so I'm not repeating that. So finding the zeros is just setting each factor equal to 0. And that way we're able to find the zeros. Now, one thing you need to get comfortable with, if I say the zeros, if I say the roots, if I say x-intercepts, these all mean the same thing, okay? If I were to ask you, what are the zeros of this equation? What are the roots of this equation? What are the x-intercepts? Those are all setting each factor equal to 0 and finding that point on the x-axis. Now, let's look at one. I want to just do a graphical example. Let me pick up a different one. Suppose I have, if I put in an x plus 4, I'll always make it a little bit easier, x plus 2 times x minus 1, okay? I expect that to have x-intercepts at what points? Negative 2, 0, and 1, 0. And that's what you see here. Let me make it a little bit broader for you. That's what I see reflected in this graph. Now, let's just do something here. Instead of x minus 1 squared, what would happen, excuse me, x minus 1, what if I had x minus 1? What if I repeated that one twice, okay? So what was the difference here? What happened? Let me just back up. So this is what it looked like before, okay? All I'm doing is I'm going to square that last term. What was the difference? So this is what it looks like with x plus 2, x minus 1. If I add another x minus 1, what happened differently? Does it still have a 0? Does it still, right here, there's still a 0, but what is it doing or not doing here that it did before? It's what? It's not crossing the axis. So if you look at it, if I only had one of those, here, in both cases, I'm crossing the axis both times, okay? But what you see here is if this thing occurred 2 times, I do not cross the axis, okay? What happens if it shows up 3 times? What did I do? I cross the axis. What happens if it shows up 4 times? I do not cross the axis. What do you think is going to happen if it shows up 5 times? It will cross. So what do you think is happening here?
So when odd numbers, odd numbers
It crosses. Even numbers, it does not. Okay, that's a key thing that we're going to need when we start building up our skills for graphing. So let's look at this polynomial. I didn't give you the equation, but the roots are at, so here's a root at negative 4. So I've got the points, what, negative 4, 0. These are my x-intercepts. Negative 4, 0, negative 3, 0, 1, 0, and 2, 0. So I want to know, what does it do at each of these points? At the point negative 4, it crosses the axis, right? What does it do at negative 3? Crosses the axis. What does it do at 1? It does not cross, okay? What does it do at 2? It does cross, right? Okay. So what do you think this means about this particular root right here? What do you think this root is happening here? It occurs how many times? Well, we just talked about what would happen. Yeah, it's probably going to have to occur twice for it not to cross, okay? So these are all the x-intercepts. This one occurs 1 time because I cross the axis 1 time. This one has to occur 2 or some even number of times for me not to cross the axis. Now, you're not going to have to distinguish between it's raised to the 4th or the 6th or the 8th. For our purposes, if it's raised to the 1st power, it crosses the axis. If it's squared, it's not going to cross the axis. So what's going to happen here is that this particular root, if I'm not crossing the axis, that root has to occur multiple times, and the number of times it has to occur is twice, okay? So let's look at this graph. So we should be able to now start telling things. Let's look at this graph. What are the x-intercepts? So what are they? Negative 3, 0. What else? Yeah. 1, 0, and 2, 0. So you want to be able to look at them. That's pretty easy. You look at the zeros. We've done that before with polynomials. Now, there is a multiplicity. That means this root occurs more than twice. Here I cross. Where's the place where I do not cross? Negative 1. So that means there is a multiplicity of 2 at x equal negative 1. That means this root has to occur 2 times. Why does it have to be there 2 times? Right. Right, even numbers or even exponents where I do not cross the axis, okay? So now let's list all of the factors of this polynomial. So what are the factors of this polynomial? These are the roots. What are the factors? X plus 3 is the first factor. What's the next factor? X plus 1. What else? X minus 1. And what? These are all of the factors, okay? But there's something special about one of these. Which one? One of these is going to occur 2 times. Which one? Yeah, this one. So it's going to have to be, you can write it like this. These have to be all of the factors. Because I know there's a multiplicity of 2 at x equal negative 1. So this root has to occur twice. This factor has to occur twice. Yes? How can I tell what?
There's a multiplicity of 2.
Because it does not cross the axis here.
But it crosses the axis.
It crosses at negative 3, okay? It crosses at 1, and it crosses at 2, okay? So each of those factors occurs 1 time. At this point, negative 1, it does not cross the axis. So that tells me this has to occur twice for it not to cross the axis. So that's why I have x plus 1 squared, okay? So for our purposes, if a factor is raised to the first power, I cross the axis. If it's raised to the second power, I do not. We're not going to deal with the fourth, the third, the fifth, and all these kind of stuff, okay? It's hard to graphically tell the difference. But you should be, when I give you a graph like this, you know that there's going to be this is x equal negative 1. That's multiplicity of 2. The factor is x plus 1. That factor has to occur twice. So you know there's going to be an x plus 1 squared that happens there. And so let's look at this example. If I see something like this that's factored, this is x minus 1 squared, x minus 2, x plus 4, okay? We will say there is a multiplicity of what number? Multiplicity of 2 at x equal what? Not negative 1, x equal 1, okay? The factor is x minus 1. So the factor is x minus 1, the solution is x equal 1, okay? There's a multiplicity of 2 at x equal 1. So if it has even multiplicity, my graph will touch the axis but will not cross. Odd multiplicity, I will cross the axis. So let's look at an example. We're pulling together some things we've done. What is the degree of this polynomial? Nope. 6. The degree of this polynomial is 6. And the way I did that, remember, this first term is going to give me an x cubed. The next one is going to give me an x squared and an x. When all of that gets multiplied, the highest term is going to be x to what power? When all these get multiplied, and you add your exponents, what are they going to be? 6. This is a degree 6 polynomial, okay? The leading coefficient. To find the leading coefficient, you look at the number in front of everything. So what's in front of this x? 1. So I'm going to have a 1 cubed. What's in front of this x? A 1 squared. And then what's in front of the next one? What happens when you multiply all of those numbers together? The leading coefficient is 1. Okay? So the reason we're doing this is these things are going to have implications when we get to graphing. So you need to be able to get the degree and the leading coefficient. What are the zeros? These are points. What are the zeros of this polynomial? Yeah, negative 1, 0. Yeah, 2, 0. Negative 7, 0. Okay, those are all the zeros. Okay. Now, which ones have multiplicity? You should be able to look at this and tell there are 2 of them that have multiplicity because they have what attached to them? Exponents. Okay, there is a look at this first one. There is a multiplicity of, what's that exponent? Multiplicity of 3 at x equal, not 1, at x equal negative 1. That's the solution. Then there's a multiplicity of what? 2 at x equal 2. Okay, so that's the way we will state multiplicity. Okay, where will this function cross the axis? Of all these points, where is it going to cross the axis? Negative 7, 0. Where else? And negative 1, 0. It crosses there because the multiplicity is what number? 3. Where do I not cross the axis? 2, 0, because that multiplicity is 2. Okay? So before I even start to graph this polynomial, I know what's happening on the x-axis, where it crosses, where it does not cross. So, in order to do this, if you look at it, let's look at where we started the lesson. If I look at the very beginning of the lesson, these two polynomials are the same. If I told you to tell me the x-intercepts, which would you rather get? Would you rather me give you this information or this information? Why? I mean, you just look at each factor, it's pretty easy to figure out what the x-intercepts are. So that's why you want it. But here's the deal. I'm going to start giving you things like this. You have to get it like this, and then you have to tell me the x-intercept. So we need skills for how to do that. So, and you've got those with synthetic division. We just brush those up over the from the weekend, and we're good to go. So what we need to do when we see a polynomial, we need to use synthetic division, okay, to reduce it down to a second-degree polynomial, because then we know how to factor that. Once we get it completely factored, then we know that we can set each factor equal to 0. Those are our x-intercepts, and we can solve that, okay? So let's do a few examples. Given that x plus 5 is a factor of this polynomial, factor it completely and list all of its roots or zeros, okay? So what is the degree of this polynomial? 3, okay? So if I do the synthetic division one time, I'm going to be left with what degree when I do division one time? I'll reduce it to a second-degree polynomial. That's a quadratic. We started in August. We know how to factor those, okay? So that's going to be our procedure. So I want to divide this by x plus 5. If x plus 5 is the factor, what is the root? Yeah, x equal negative 5 is the root or solution. When I go to set up synthetic division, what number goes on the outside? Negative 5. Okay, so negative 5. And then I need to set this up. So I'm going to have something cubed, something squared, an x term, and a constant. Okay. What numbers go now? What numbers go in here? 1, 3, negative 18, negative 40. Okay. So what's the first thing that happens? Yeah, the 1 comes down, and then what? 1 times negative 5, and then what? Negative 2, and then I multiply negative 2 and negative 5 to get 10. Negative 18 plus 10 is negative 8. What's negative 8 times negative 5? 40. I'm in love with this problem at this point because what did I get in that final answer? A 0. No remainder. That means that x plus 5 is a factor. X equal negative 5 is a solution. Okay? So how do I read this answer? This is x to what power? Squared. This is x. That's constant. That's the remainder. Okay? So I now know that this polynomial, p of x, is equal to, okay, what is the factor that I know? X plus 5, that's the first factor. And then what am I left with? What's that bottom row telling me? X squared. Okay. So that's what happens when I factor out the x plus 5. Okay, now I need to factor this completely. Which part do you think I need to work on now? I got to work on this. How do I factor something like that? What do I do? Yeah, so I need two numbers that multiply to what? Negative 8, and they add to negative 2. What numbers possess those properties? Yeah, negative 4 and positive 2. Okay, that means that this is p of x equal x plus 5. And then what's the factorization of that next one? X minus 4, x plus 2. And I'm done. That's the complete factorization of this polynomial. Now, what are all the roots of this polynomial? What are the x-intercepts? negative 5, 0. What else? 4, 0. And negative 2, 0. Do any of these roots have multiplicity? No. What would be my clue that there was multiplicity? One of them would be squared or cubed or something like that. So what will happen when I graph this at each of those points? I will cross the axis at all three of these points. And there is nowhere else I will cross the axis. Because if I cross the axis anywhere else, that would be I have another solution. If I have another solution, I also have another, starts with an F, factor, which I don't. These are the only three factors. There can only be three roots or three solutions or three x-intercepts. Okay, so that's what we're going to spend a lot of time in this unit, taking polynomials that look complicated and trying to get them to where we can factor them. Okay, right now I'm giving you hints. I'm telling you x plus 2 is a factor. That tells you how to start the synthetic division. What we'll get to later is how you do that when I don't provide you that hint, but that's for later, and that's to keep you up at night. So if x plus 2 is a factor, how do I set up this synthetic division here? Negative 2 goes on the outside. Okay. And then just double check. This is a cubic, so I'm going to need x cubed, x squared, x, and constant. So what are the numbers that go here? Are going to be what? 3, 5, negative 4, negative 4. If I bring the 3 down, negative 2 times 3 is negative 6. Add to get negative 1. Negative 1 times negative 2 is 2. Add to get negative 2. Negative 2 times negative 2 is 4. Add that to get 0. Okay. So this is my, what term is this? My x what? Squared, my x, my constant, and my remainder. Got a 0 remainder. So this polynomial, p of x, what's the factor that I just found? X plus 2 is the factor. So write that down, x plus 2, and then what is the remaining factor? 3x squared, what? Minus x minus 2, okay? So I want this to be completely factored. I've got it down to a linear term and a quadratic. I need to factor this quadratic, okay? How do I factor 3x squared minus x minus 2? Okay, to do that, I need to find what? Two numbers that do what? Multiply to negative 6 and add to negative 1. What numbers multiply to negative 6 and add to negative 1? Negative 3. Negative 3, positive 2. Those multiply to negative 6, they add to negative 1. So negative 3, positive 2. Now, what do I do with these numbers? I go back to this original equation, and I have to write it like this. 3x squared minus 3x, remember this, plus 2x minus 2. I do it this, now I can factor by what method? Grouping, okay? That means I look at the first two terms and the second two terms, okay? What do the first two terms have in common? 3x, and I'm left with what? X minus 1, plus, what do the next two terms have in common? 2, and that's 2x minus 1. Okay, so then how does this factor? What's the factorization? Yeah, 3x plus 2 times x minus 1. So my final answer here is p of x equals, yeah, don't forget the one that you did up at the beginning, x plus 2 times 3x plus 2 times x minus 1. What are the roots, the zeros, the x-intercepts of this equation? Negative 2, 0. If you don't know this one off the top of your head, 3x plus 2. What happens when you say 3x plus 2 equals 0? That means that 3x is equal to what? Negative 2. So x is equal to what? Negative 2/3. So this is what, negative 2/3 0. And what's the other one? 1 0. Is there any multiplicity to any of these roots? No. So what will happen when I graph this at each of those points? I will cross the axis, okay? So right now we're not doing the graphing. That's going to come a little bit later. We just need to make sure we're pretty solid on the algebra skills. Now this one's a little bit different. What's different about this one? I've got two factors. The others started out being what degree? The two we just did were what degree polynomials? Third degree. What's this one? If I start with a fourth degree, how many times does synthetic division need to work before I get down to a second degree? Twice, okay? And what's your clue? And I'm telling you that x plus 2 and x minus 1 are factors. So that means that x equal negative 2, that's one of the roots. What's the other root? X equal 1, okay? So the degree is a fourth degree, and I'm going to need to reduce this down to a second degree so that I can factor it. So I'm going to start with which numbers outside the synthetic division? Negative 2. You could start with the 1, doesn't matter. But I'm going to start with the negative 2. So negative 2, and like I said, you don't have to do this point, but this helps me to never miss when I need to plug a 0 in. Okay, so I need numbers for all of that. What's the coefficient of the x to the fourth term? 1, 2, negative 3, negative 4, and 4. Okay. The 1 comes down. What's 1 times negative 2? Negative 2. What's 2 plus negative 2? 0. What's negative 2 times 0? Plus negative 3? Negative 3. What's negative 2 times negative 3? 6. 6 minus 4 is 2. What's negative 2 times 2? Negative 4. That adds to 0. Okay. Now this is going to be what? X cubed, x squared, x constant remainder. So I've divided it by x plus 2. Now what do I have to do now? I've got to divide it by what? X minus 1, or test to see whether or not x equal 1 is a root. So what I'm going to do here is I'm going to do this process. Sorry. I'm going to do this process again. Okay? So rather than write out the answer of where I am, I need to do it again. So I know at this point, I know that x plus 2 is a factor. Okay? So I've already proven that x plus 2 is a factor. Now I need to find that x minus 1 is a factor. So what happens when I bring the 1 down here? 1 times 1 is 1. 0 plus 1 is 1. 1 times 1 is 1. Negative 3 plus 1 is negative 2. 1 times negative 2 is negative 2. Add that to get 0. Okay? So if this was my x to the fourth, this would have been my x cubed. What is this going to be? X squared, x, and constant. Okay? And what does this mean? What factor did I just find here? Those are the two factors that I know. I was given that information to start with, x plus 2, x minus 1. Question, Michael? Okay. So let's look at where we are now. We've got this polynomial we started out was a fourth degree. What are the two factors that I know? X plus 2, x minus 1. When I factor those two expressions out, what am I left with? X squared plus x minus 2. Okay? Now what has to be factored? The quadratic has to be factored. Okay? So now it's just boiled down to what we started the class with in August was factoring a quadratic. How do I factor x squared plus x minus 2? I need two numbers that multiply to give me what? Negative 2 and add to give me 1. What numbers can multiply to negative 2 and add to positive 1? Multiply to negative 2, add to positive 1. -1, +2. Okay, so what do I do with those numbers? Yeah, this is, I don't have to do grouping because this is a 1 in front of the x squared. This tells me this is just x minus 1, x plus 2. Okay, so my final answer here is P of x equal x plus 2, x minus 1. And then we just determine x squared plus x minus 2 is x minus 1, x plus 2. Yeah, so you could say, well, I could rewrite that as P of x is x plus 2 squared times x minus 1 squared. So if I go to graphing this, now I have some important information. What are all the roots and zeros here? What are the roots or the x-intercepts? -2, 0, and 1, 0. Is there multiplicity? Yeah. So in this case, I will say there is a multiplicity of how many? Multiplicity of 2 at x equal -2 and at x equal 1. So when I go to graph this, what's going to happen at those 2 points? I will not cross the axis, okay? So again, that will come later, but just the algebra of it is the thing we're trying to get solid on here. So we did synthetic division earlier. You need to be solid with that to factor polynomials. So and you need to be real solid on, if I give you a root, you know the factor. If x equal 4 is the root, x minus 4 is the factor. And then if a root occurs multiple times, we will say, like this has a multiplicity of 3 at x equal 2. And then you'll know graphically when we get to that what comes in. So what I want you guys to do I want you to work on this one before we go. I think that's the last thing. So I'm giving you one just like the last one we did. It's a 4th degree polynomial. I'm giving you 2 factors. See if you can use these 2 factors to get down to the quadratic and get it factored completely. Okay? go ahead, sir. So you got factor with the 2.